Hey everyone, welcome back to The Explainer. Today, we're actually embarking on a bit of a true intellectual detective story. We're going to map out a massive paradigm shift in computing, tracking how decades of isolated theories and philosophies finally merged into this entirely new type of technology. It's all about breaking down the rigid barriers of traditional computer science. And you know what? The solution comes from literally one of the most unlikely places imaginable.
Okay, I know. It sounds exactly like the setup to a bad joke. What does a hit country song have to do with complex database architecture? But to understand the totally groundbreaking software patent we're looking at today, we first have to solve the mystery of how a musician and a copyright lawyer somehow ended up reinventing data storage. Because it turns out the architecture of this new database, yeah, it wasn't born in a traditional computer science lab. It was actually born somewhere right between Music Row in Nashville and Bay Street in Toronto's financial district.
And the inventor of this architecture, Kyle McLean Smith, is on the record stating that his non-traditional background wasn't just helpful, it was absolutely, strictly mandatory. He said, and I quote, he simply wouldn't have had the written language skills to conceptualize a database program hybrid without his music and law background. So let's unpack exactly how that actually happened.
Which brings us to Section 1, the music lawyer's breakthrough.
So, as we established, Smith definitely didn't start out in a computer lab. Back in 2006, he graduated with a music business degree and even competed in a country music showcase. But as he moved into music publishing and eventually went to law school for intellectual property, he found himself at a firm representing absolute tech giants, think Microsoft and Amazon. And this close proximity to deep tech, completely combined with his roots in the music industry, well, it planted a very, very unique seed.
While he was deep in the weeds of musical rights and copyright management, Smith had this profound realization. He saw that music licensing agreements are, fundamentally, just structured hierarchies managing relational dependencies over time. Right? A single song has a writer, a publisher, performers, and distributors, and they all have these intricate contract-based royalty schemas. A percentage goes here, a flat fee goes there. Smith realized that this complex, multi-level royalty split mathematically mirrors intricate database schemas. I mean, think about it. A song's royalties are basically just a massive automated spreadsheet of who gets paid what and exactly when. It literally took an outsider's view of complex legal hierarchies to rethink basic computer science. But he still needed the technical chops to actually build the thing. So let's move on to Section 2, the 2013 Stanford Catalyst. The precise spark for this invention was actually Balaji Srinivasan's 2013 Stanford Coursera MOOC. That's Computer Science 184, or Startup Engineering. Now, this was not your standard coding class. It was completely unique because it combined 50% technology with 50% venture philosophy. Srinivasan, who had left Stanford academia to build a massive clinical genomics startup called Counsel, realized that traditional academic computer science often just flat out failed to teach students how to actually build and deploy real production software.
So the crucial point here is how this course brutally shifted the focus. It moved way past dry academic theory, like balancing red-black trees on a chalkboard, and focused entirely on the pragmatic, hands-on, full-stack survival skills required to build real functioning apps. We're talking customizing Linux command lines, managing distributed version control via Git, and designing REST JSON APIs. It fully bridged the gap between theory and production. And it was exactly within this specific curriculum that Smith found the technical foundation for his database.
All right, Section 3, the JavaScript singularity.
In traditional software, you have this massive efficiency problem, and it's known as the von Neumann bottleneck, or integration friction. Basically, the database, which is the storage, and the application, which is the brain, are completely separated. And because they're apart, they are constantly forced to translate and ship data back and forth over a network, creating this massive bottleneck of wasted time and energy. It is highly, highly inefficient. But the MOOC emphasized something called server-side JavaScript, or SSJS. And this is exactly where Smith's vision clicked into place. He realized he didn't need two separate systems. He could just use JavaScript as one single language to rule them all, executing commands and retrieving data in one singular place. Instead of separating storage and compute, he pursued total efficient coupling, a single JavaScript kernel where the retrieval path and the execution path are identical. A real game changer. Moving right along to Section 4, the architecture of exit. Now remember, that Stanford course was 50% philosophy. Srinivasan taught a concept called regulatory exit, drawing on Albert O. Hirschman's framework.
The idea is, instead of trying to reform a stagnant or broken legacy system from within using voice, you use exit, meaning you withdraw entirely to build parallel alternative infrastructure. Srinivasan used the 1991 repeal of the National Science Foundation's commercial internet ban as the ultimate historical precedent for unlocking new parallel ecosystems. And Smith took this absolutely to heart. His thought process was basically, why try to fix a broken database system when you can just exit and build your own entirely new infrastructure?
So Smith ultimately filed U.S. Patent 12,664,142. And getting a software patent post-Alice, which is the 2014 Supreme Court decision that gutted a lot of software patents, is notoriously brutal. You have to prove incredibly specific technical improvements to computer hardware functionality. But Smith didn't go through this massive, expensive legal battle just to hoard the technology in some proprietary vault. Nope, he used his IP law background to secure the patent specifically so he could enforce open-source attribution, functioning exactly like a music royalty structure. He actually built a legal framework directly into the architecture of the database to protect developers.
Okay, Section 5, Crossing the Semiotic Bridge. Let's actually move to the physical architecture itself and see exactly how this linguistic framework unified code and data. Smith uses this brilliant analogy called the semiotic bridge. He explains that traditional computer science has essentially forced us to communicate using isolated nouns in one system, meaning the passive data objects sitting in a database, and isolated verbs in another system, meaning the execution logic sitting over in an application server. They are entirely disconnected from one another.
So the crucial point here is how his invention, the Hierarchical Script Database, or HSDB, completely bridges this gap. By utilizing a single JavaScript kernel, it literally puts these nouns and verbs right next to each other in cohesive sentences and paragraphs. When a parent node in this tree data structure receives an event, it doesn't just passively store it like some digital filing cabinet.
Instead, that parent node actively spawns a new child node to handle the data. These are active, self-reproducing pieces of code executing their own logic within a sandboxed interpreter environment. The database organically grows, updates, and mutates itself. Honestly, it's almost like a biological organism. And it does it without needing a centralized controller telling it what to do. It mathematically enforces code data locality.
And finally, Section 6, the future of IP.
This whole thing represents a stunning convergent evolution, right? From the early NoSQL concepts of the mumps database way back in 1966 to the power of regulatory exit proving itself with the commercial internet being unlocked in 1991, straight through the pragmatic engineering of the 2013 Stanford MOOC. It all culminates in 2020. Smith's HSDB patent perfectly unifies code and data into one seamless structure, and it's all protected by an open-source legal framework.
Which leaves us with one final, kind of mind-bending question. You see, Smith viewed this unified code as a dynamic creative asset, just like a musical composition. But if the nouns and verbs are perfectly unified, if the script is the data and the data is the script, where does the database end and the application actually begin? Thanks so much for joining me on this explainer. Keep questioning the architecture around you, and I'll catch you next time.